Welcome, Physics 2. Welcome to a new week. Last class, you guys had given me lots of good feedback on how to make the class better for you. So I went ahead and put a lot of that stuff into action today, so we'll see how we did. Today we are going to be reviewing topics 2.2 through 2.4 to get ready for the end of the year assessment that we'll have later on. The homework today is just going to be to work on one quiz. We'll look at that in just a second. So I went ahead and just summarized some of the things that you had asked for me to do differently. So I tried to put a lot of that into action today. One of the things I like to focus on now is the fact that I'm having a goal for each class for you guys to spend 1.5 hours. For some of you, that means you really need to spend more time working harder on stuff. For some of you, that means you need to call back and not do every little detail of everything. So again, make it your goal today to be 1.5 hours worth of work for the total day, 3 hours total for the week. Let me know how it goes. I also want to encourage you guys to get together in groups and work in partners. So for the most part, even including the quizzes, all of this review that we're going to do, I'm going to open it up to you guys working in partners and working collaboratively. So do that. Get together with each other. I went ahead and put together this lesson today for you to do some reviews. So if you guys would go ahead and get your formulas, calculator, pencil, course companion study guide out. Last class, we had a quiz, and I just want to go over that quiz really quick with you. First question was asking about a skydiver. So one of the things to note in this question right here is that as the skydiver pulls the parachute, they went from a really high speed to a lower speed. So their acceleration vector is upwards, and the velocity vector is still downwards. They are still moving downwards. So the correct answer for this one was C. Number two was asking you to think about some kinematics here. And so you notice a stone is thrown off a cliff, has an initial speed. How high is a cliff if it hits the ground 2 seconds later? So in this one right here, let's go ahead and switch gears to this app here. I was just using the equation of D equals UT plus 1/2 GT squared. Okay, that was the kinematics equation. And if you notice, we have our initial speed and time, and our G is 10 and time squared, and that gives you the correct answer there. So let me pull that off for you. And so the correct answer for this one, by the way, was B, 30. Okay, next one here. Got a question about some uncertainties. And so for this one here, this is a density problem. So I'm going to go ahead and show you back with the board again here. So in this question here, we're basically saying density equals mass over volume. And if you remember that uncertainties always add, our uncertainties for the mass was 8%. And since volume is a cube thing, each of the dimensions was 4%. And since they always add, everything always adds. Okay, this is going to add to this, to this, to this. That just equals 20%. Okay, so you can kind of see how that works there. And see it over there, 20%. I can see it there, whatever. Okay, all right. So next one here, let's move on. All right, so next one is... this one here is looking at a projectile. And what we're seeing with the projectile here is that they're asking you from point O to point P, what's happening to the horizontal component. So in projectile motion, if there's no frictional forces, horizontal component always stays the same. And so it's constant. And then from here to here, the vertical component of velocity is increasing towards the ground as it goes down. So the correct answer for number 4 was A. Number 5 was another uncertainty question. So we'll go ahead and put that one back onto the flex camera really quick. Okay. And for this one here, we're actually just using the equation for D equals 1/2 AT squared. And what we have here is you have got the uncertainty, the fractional uncertainty was 0.2 over 2, which gives us a fractional uncertainty of 1 plus or minus 0.1 second for the time. And because that gets squared right there, that uncertainty is going to double. So we have plus or minus 0.2 seconds. And if we look at that plus or minus 0.2 right there, compared to the total time, which was 20 in this case, what we end up with is plus or minus 4 and meters right there.